All right, this is chapter 2, part B. Can't write B there. So we're going to look at hexadecimal. This is using base 16. So again, what we do on the top, this is hex 2 decimal. So we write, since we're using base 16, we have to do the powers of 16. So 16.0 through 16.4. That's power 4, not 164. So if you look at, if you convert them, if you raise these to all the powers, you get 16, 256, 496, etc. So what we want to do now is take the hex number, which I have 1A2, any hex number I want. So in this case, 1A2. And what I'm going to do now is convert that. So the next step is you write down the powers, the values of the powers, and now you have your value of your hex. This is what we want to find. This is what we want to find right here. And then we're going to multiply. Well, this is similar to what we did before, but a little bit different. So if we look at 2 times 1, that's 2. Well, 16 times A. Well, 16 times A, well, A is what? Well, if we look at the tables of A, B, C, D, E, F, and G, we have to look at those. So A, B, C, D. And then A would be, if decimal is 10. So we're looking for the decimal value of A. So 10, 11, 12, 13, B, C, D, E is 14. And F is 15. Woo! Good stuff. So we look at A. Well, we can't just take A times 16. We have to look at the value of what A is in decimal. So it's 10. 10 times 16. So this is going to be 10 times 16. So this is A is actually in decimals 10. So 10 right there. 10 times 16 is 160. And then we have 256 times 1 is 256. So now we do is add. This is the add part. So we do 256 plus 160 plus 2. So 256 plus 160 plus 2 gives me 418. 418 in decimal. So we're going to put it as a base 10 right there. Pretty straightforward. Not too hard right there. Let's do one more. This time I'm not going to go up to 6. I'm going to go up to 16.3 here. So 16 raised to the 3, 16 raised to the second, 16 raised to the first, and 16 raised to the 0. I'm going to write these values out. 116, 256, and then 4096. So now I'm going to do is, this is my powers converted. Powers converted. Now what I want to do is I'm going to put my hex value I'm looking for. Let's do this again. Let's go with B, and let's go 3. 3BBB is our hex number. Okay. So now we want to do is we're going to multiply. So B, we have to look at our cheat table here. And B is 11. And decimal. So 11 times 1 is 11. 11 times 16. Well, I'm not using that on my calculator. Well, that should be easy. You can just take 10 times 11 is 110, and then you take 6 times 11. So I'm just going to do the calculate 176. And then 3. And then finally we have to add. So we add. So we have plus 3 plus 11 is 190 in decimal. So that's the answer. So now we want to do is convert decimal to hex. So we're converting, let's say we're going to convert 47 decimal to a hex value. Well, the other way we did multiplication, opposite multiplication, division. So we take 47 and we divide it into 16, and now you're going to have a 2, and this gets a little bit crazy here with the remainder of 15. Okay? And I'll explain to you what's going on here in a second. So we know that 15, we can't just, because we're going to hex, we have to look at our cheat sheet. 15 is an F, so we're going to just put the thing F just like right there, just like that. So there's that. Now we have to do is take the 2, and we're going to bring it over, and we're going to do 2 divided into 16, which is going to give us a 0, and with the remainder of 2. Of 2. So our answer is 47 base 10 decimal is equal to 2F. All right, so if we actually use the calculator and we put a 47 divided into 16, you get actually this number, which is a decimal. If you have some calculators that actually give you a fraction, you probably get the fraction or the part of it, but always keep it in the decimal. The problem we have right here is that we have 2.937, that's 47 divided into 16. See, 47 divided into 16. So this 0.9375 is where we get the 15. How do we get that? That is the question. How do we get that? Well, if we take 0.9375, would help my calculator to not, let me go down, I'll clear that. I'm going to head down one line here. 0.9375 better, times that by 15, because that's the number right there. Not 15, times it by 16, excuse me, not 15, 16. Watch what happens. We get a 15. That's how we get 15. So again, we take 0.9375, times it by 16, because we're base 16, or that's where we're dividing, and we get 15. So that explains one way of actually doing this. So let's do another one. Let's actually convert 66 base 10 decimal to hex 16. So we do 66. What are we dividing it? 16. 66 divided into 16. 66 divided into 16. We get 4, and now we have that decimal. Let's say it's 4. Let's see, I got 4.125. Well, if I take the 0.125 times it by what? 16, I get 2. So I get a remainder of 2. Now we take the 4 divided into 16. 4 divided into 16, I'm going to get a decimal of 0.25. So I'm actually going to get nothing there, but I get a remainder. I get a 0 here, and I get a remainder of, well, in this case, it's 0.25. See, I got that 0.25, and I take that 0.25 times it by 16, and I get 4. So what I have here is, this is 42 in hex. Okay. All right, so Octal Definer is similar to hex and the decimal. The only difference is in the octal numbering system. I'm going to show you what this looks like in the textbook. So if we look at the text, that's the octal numbering system. You notice that once we get up to 7, it doesn't go to 8, but it actually jumps to 10. And then again, it repeats. But the nice thing about it, if you take a look at this, is that once we get to 7, you notice that we're using only 3 bits on this. So the nice thing about octal is that we can actually easily convert from the binary to the octal, and then because we're only using 3 bits here. See how it's only using the 3 bits right here? 1, 2, 3. 1, 2, 3. 1, 2, 3. So once we get here, we have to jump over to this bit, and then we continue counting. So that's the interesting thing about octal. So to do octals, it's similar to the numbering on conversion. So if we actually do some conversions on it, so we do the conversion. Let's say you take an octal number. Let's go with 7, 6, and let's go with 7, 6, and 4. So 7, 6, and 4. So we have this octal number. We want to convert it over to a decimal. So we want to go to decimal. So there's our octal. So now what we want to do is we're going to multiply, right? We have to multiply. So the next step is multiply. So 7 times 1 is 7. 6 times 8 is 48. I'm going to get you in a second. And 64 times 4 gives me 256. So I'm multiplying. Okay, so now we have to multiply. Now what we have to do, add. We finally finish up add. 256 plus 48 plus 7 is 311. That's an octal. Remember, octal is base 8. Base 8. Okay, Division is similar. I'm not going to go through division because I really don't. I mainly want to focus on decimals, binaries, and hexes. So if you have any questions, please reach out to me on that. So that's Octal Definer. Finally, what I want to talk to you about is I've been talking about bits, nibbles, bytes, and all that. So just a real cash on this. When we actually start getting into some of the more deeper stuff, when we start getting into logic gates, we're actually going to be using bytes and nibbles and bits. Maybe get some words here. So a byte, what is a byte? A single binary value. It's a 1 or a 0. A nibble is 4 bits. So that would be like 1001. A byte is 8 bits. 1001, 1001. That's 8 bits. And a word is 16 bits. So that's actually double of the 8 bits. You notice that this is just doubling, right? This is, you have 4 here. Now you just double. Another 4, another 4, another 4, etc. on that. So words, double words, etc. This book talks a little more deeply about this. So the biggest stuff I want you to learn on this is actually to learn how to convert the hex to decimal, binary to decimal, and decimal to binary, decimal to hex. That's the biggest obstacle. Let's see if there's anything else I want to cover on chapter 2 for you. Let's see if there's anything else I want to chat. Octal number, bits, bytes. I'm going to look at the chapter 2 ending. So just do the review questions, and I'll see you back in class.